Good morning, Sally, and thank you for joining us today. I'm very familiar with your work, and so I'm excited and honored to have this opportunity to chat with you. I know you've been fairly popular on the podcast circuit as of late, and while most in the holistic health space are likely familiar with you and your work, there will be those who maybe aren't as familiar with you, especially in our audience over in the UK. Would you mind introducing yourself and running us through your story?
Well, I have been a nutrition geek since kindergarten, since I was a little preschooler. Long time interest in trying to be healthy. And in middle school, when I was about 12, I had this insight in science class. I was like, oh, you mean you can avoid major chronic diseases potentially because nutrition has a major role in whether you get really sick and a major role in prevention of disease. And so I've been trying to do well since I was a little child, eat just the right things. And unfortunately, I did everything right, but struggled with health problems from early on in life. And it became disabling in college, in graduate school, and again, over and over again. I'm running into major problems that are interrupting my career. And I was at a loss for answers. And I'm in my late 40s. I'm an expert in holistic and healthy living and therapies and integrative medicine and public health and nutrition, successful aging. And I didn't know what was wrong with me. And neither did my colleagues in functional medicine and holistic healing and standard medicine. Nobody was pointing me to the answer until one symptom in 2009 pointed me to an outfit online called the Vulvar Pain Foundation. Vulva pain is a genital pain of burning that ruins your life. And it took me another nearly 4 years to really have this breakthrough insight that brought me into this mind-bending realization that led me to more and more surprises as I started to get better by taking out my lifetime of spinach, beet greens. It was really Swiss chard, sweet potatoes, and holy cow, all kinds of old problems started unwinding themselves. So I talk about this in my book, Toxic Superfoods, and on my website on the About page. There's a little summary of, wow, I had to really get over all the knowingness of all my knowledge and be desperate enough to recognize that the enemy was right on my plate in my organic garden, in my kitchen. Wow. Yeah.
Talk about being fed a lie. I think I came up with that on this. Sorry, that's my best joke for the day.
Unfortunately, we're feeding lies to pregnant women and babies too. I mean, we can kind of laugh at our own suffering and go, oh, well, at least she made it to her 60s and got through that somehow. But if only we had known this earlier in my life, and only if we can now help others, because we're in an age now with the foods that we're supplying this damage to my life are universally revered and trusted and assumed to be innocent.
Yeah, and I think that's definitely a point we'll get on to later on in the podcast. Thank you for that. You're a star. I reckon we might as well get into the meat and potatoes, or I suppose the spinach might be more applicable of today's conversation, which is oxalates, and you've obviously already alluded to them. But at a high level, could you explain to the audience what exactly oxalates are? I know you've mentioned some food sources already, but what are these plant chemicals that seem to pose such an issue for so many people?
Right. So plants make this oxalic acid. Oxalic acid is a small little molecule. It's a chelating acid, 2 little carbons with 4 oxygens, which is really interesting that it's so heavily oxygenated. It's really dicarbolic acid. So this thing likes to grab positively charged ions like calcium, magnesium, all the minerals out there tend to get bound up with oxalic acid. And then we call that an oxalate when it's in connection with a metal. And these oxalates form bonds with each other, little pairs of them, groups of pairs, about 8 or 12 pairs come together and they form nanocrystals. This is crystallization, and start to build into crystals. Those crystals are commonly seen in kidney stones. So oxalic acid that plants make soils make it, from the funguses and so on in the soils. It even is made, it's so easy to make it in nature. Clouds with a little bit of pollution and moisture will form oxalic acid. We've had a problem here in the eastern United States of acid rain. It turns out oxalic acid is the major acid in acid rain, and it melts monuments and causes problems with soil pH and so on. So it's everywhere. It's ubiquitous in nature. A lot of plants make it so much of it that they're completely inedible. And then there's the ones we've bred for the produce aisle, which have less, but some of those we cannot seem to breed well enough to get them low enough to really be safe. And somehow we're ignoring it. So yeah, oxalic acid, oxalates, it's said in the plural. It forms these different forms from an acid to a molecule to a crystal. Different kinds of minerals can be connecting to it, and it can change places and move around. So we call them oxalates plural. We're talking kind of generally about crystals and an acid, a free acid, and they have different properties and different tendencies in the bodies. So it's important to kind of know there's this soluble acid, and then there's these insoluble calcium oxalate crystals, which become a crystallization in the body.
Yeah. And are oxalates, I suppose, produced at all in the human body endogenously? Do you humans produce these molecules, or do they just come from diet?
Well, you can eat it directly in the foods that are all plant foods. Animal foods don't have it. And then there's the transformation of precursor molecules into oxalic acid, and that does occur in the body to a small degree. We produce about an average of 12 milligrams daily in this sort of endogenous process. But the very interesting thing about it, if you understand what these precursor molecules are that become oxalate, you realize the big one that's producing more than half, probably at least 40%, maybe much more than that, of this endogenous production, this little 12 milligrams, is coming from vitamin C supplementation.
Oh yeah, no, and I think there are a bunch of other offending supplements out there, such as glycine, that can also contribute as well, as
Glycine
far
is
as I know.
not so bad. It's a pretty small amount. It's a hydroxyproline is worse, which is in collagen. So if you're
Yeah,
using whole collagen and you're using more than maybe 4 teaspoons a day, which is, what is that?
20
20
grams or
mils.
so.
20 mils. Yeah. So that's enough to start generating more oxalate in the body. But it's still a relatively small amount, but people literally can feel the difference when they quit overdoing the collagen supplements or they stop the vitamin C. Those two things can be major ways of protecting yourself from this so-called endogenous production. But to me, if it's coming from something you're eating and have an option to not eat, that's not really endogenous production so much, just because the transformation's occurring inside the body. So it's a kind of a misnomer that's been abused by people who want to just have carte blanche to eat what they want. Like, your body's making it anyway, so what? Well, with toxins, your body does make toxins. That's why you pee it out. That's why you make feces. That's why you peel off your skin and you sweat and you have lymph glands and all this stuff, because you're moving toxins out of the body. Even the fluids from the eyes, you're moving toxins out of the body. Of course, the body both receives and creates toxins, but it doesn't mean that gives you permission to start pigging out on toxins. It doesn't make
Yeah, of
sense.
course. Yeah. I suppose that sort of almost begs a question. Is there any reliable data on why we have oxalate in the body? Is that something you know offhand? Maybe is there a sort of a place? Is there a biological requirement for oxalate at any level, or is it something that is it purely something that is introduced to our diet that shouldn't be there, that causes more problems than it's worth?
Right. So this is a potentially complex conversation, because we see sort of free radical production by mitochondria as signaling molecules that helps the body make more glutathione and start fighting back and do good things. So there's sometimes something that's too much of it is bad, a little bit is good, and the right environment is good. So is a little bit of oxalate good or not? It's never shown up as being a signaling molecule that's creating some kind of defense response. And the only possible advantage that I've seen is that the oxalate that's concentrated in the saliva might actually form a tartar on the teeth that's somewhat protective. But in the mitochondria in the cells, they would do fine without something that's ruining the membranes and interfering with enzyme production or enzyme function and causing all kinds of oxidative stress using glutathione. There isn't really, there are people who wish there was, and they're not the real scientists who are saying, well, we don't see it.
You've already answered this in a sense, but I'd love to get a clearer picture here. As I've alluded to earlier, I've listened to several of your conversations you've had recently, especially with individuals with, let's say, more restrictive ideas and ideologies when it comes to diet. So your Anthony Chaffees of the world, who are obviously fairly fervent believers in the idea that plants, all of them, are trying to kill us. Now, I do think a carnivore diet is definitely a useful tool for certain people at certain times in their lives, and that it can be very effective as an elimination diet and all of that. I suppose this is a bit of a broader question, but where do you stand on the spectrum? Do you feel that we should be getting rid of most plant matter for the whole part? Or do plants have a place in the human diet? I suppose what I'm asking is, are vegetables trying to kill us?
Well, we don't necessarily want to do a prescription for all of humanity yet, but if we're thinking just generally in principles about what is humanity meant to be eating and what's really optimizes health versus what you can get away with, I mean, there's all kinds of angles you could take to these questions. If you're interested in optimization and protecting the health of the future generations, and you're really interested in seeing functional longevity, not just hospital-based longevity and drug-supported fake longevity, but actual vital, functioning, healthy, full life living up to some nice, ripe, old, mature age. There's a lot of questions there about whether plants at all are necessary. Can you live that optimal life, and can you produce healthy generations going forward without plants? And there's evidence that you can. There's peoples on this earth who've lived in areas that don't have any plants, like the ice poles, the northern regions of Alaska and that kind of place, have done pretty well without much plants at all. And certain tribals, people like the Maasai, traditionally in the old days would have very few plants. So we know that human beings don't necessarily have to have plants to be healthy. And that in itself is a huge controversial idea, because we've been told in modern life that plants have essential planty stuff, these phytonutrients. You got to have them. They're going to give you longevity and all this stuff. But that is standing on a pillar of jello, because we came up with this idea that there were these antioxidants in plants as a back of the envelope placeholder that hasn't held up at all. They have not been able to demonstrate any kind of consistent way where, say, polyphenols or whatever consistently in all people have this beneficial effect. And if and when it has a beneficial effect, it's because it's interacting, luckily, with certain genetics and certain microbiome in the colon. And if you don't have those genetics and that microbiome, and you don't know which ones to use, there's tens of thousands of polyphenols and so on, we have no way to actually use that concept effectively for all people. And what's happening is that we have this selective idea of this benefits-only mindset. So there might be something great in plants, maybe, sometimes, probably, okay, but which ones, how much, and so on. We've got this blind spot around, well, what about the anti-nutrients in plants? Toxic chemicals, generally, their effect on illness and aging has been overlooked for a long time, in general, by everyone, including science. And with oxalate, and science is very familiar with the toxicity of oxalate, and yet clueless about the impact of oxalate in our foods on our health in the short and the long run, on reproductive health and so on. And modern research is so over-focused on kidney stones, and they have an agenda that would have them pretend we don't know that diet is supplying the required material to become kidney stones. If you say that, then why do you need funding forevermore? Why do you need to captivate all funding on oxalates for 70 years when you're busy pretending it's not made of the stuff you're eating. And we know that the diet is the main cause of that. So there's a lot of things around us that are affecting our viewpoint about diet. Personally, I do think plants have a right to take care of themselves. We need to be less Disney-fied in our thinking. Like, we have to be a little more logical. You have to think the science is not a Disney movie, or nature's not a Disney movie, but nature is claws, lightning, fire, death, destruction, hurricanes. Like, nature's a rough place. So oxalate is a tool harnessed by plants brilliantly for their own survival and self-defense. They cannot afford to play nicey-nicey like they do in Disney movies. They have to take care of business and survive. If they were completely non-toxic, they'd be extinct.
And what do you think about fruits in that regard? I mean, fruits have a different sort of biological imperative. I mean, they contain seeds. The idea being there, obviously, that the aim is for them to be ingested so that those seeds can then be dispersed across the landscape, and that plant can, well, in this case, that fruit can then seed and produce more offspring. Do you think fruits carry the same level of issues
Well,
potentially?
you can say the same for nuts too, because nuts are squirrels and other vermin are very busy, interested in nuts and burying them for the trees and so on. And so trees and plants are using the mobile animal kingdom to support that seed distribution as they use wind and water and other natural tools to disperse their seeds. There are plenty of berries on plants that you would never let a child eat because only a bird can survive eating them. So fruits aren't necessarily needing us to survive to have that dispersion, because there's other creatures helping them disperse. So it's a mixed bag, but for the fruits in the produce aisle that we've bred and bred and bred to make sweeter and more interesting and more full of calories and enjoyment, most of them are okay in terms of oxalate. And the main exceptions are blackberries, kiwis, figs, pomegranate, plantain, raspberries as well, and star fruit is absolutely poisonous. But most of the other fruits are fine. And so here's a chance to get into the geeky, nitty-gritty distinction in oxalates. So there's soluble oxalic acid and then there's calcium oxalate crystals. And the fruit seems to have the insoluble oxalate, so they're probably very small crystals attached to membranes and fibrous materials. And they're probably not as absorbed into the bloodstream. So the acid moves between cells of the gut and gets into your bloodstream pretty easily and fairly quickly, right up in the stomach and upper small intestine. Whereas this insoluble stuff would take a long time, maybe all the way to the colon before it's available for absorption, if at all. So you don't get as much of it messing with your blood system, your blood cells, your vascular system, and your organs, just messing with your gut. So the fruit is more likely to deliver these crystals that are pretty hardcore. Like the kiwi has the toothpick shaped crystals, the raphides, and these are bundles of hundreds of these little toothpicks with points on both ends that are designed to penetrate the mucosal cells 2 cells deep. But technically, the cell lining of your intestinal tract is only 1 cell deep. So you're eating ground glass when you're eating kiwi and things like this. And that's causing oxidative stress or mechanical abrasion, which is a type of toxicity. So it's a different kind of toxicity. So fruits in moderation, no problem, probably. And yeah, I think we need carbs. I think we're drawn to carbs. We have sugar tasting tongue. We're attracted to it. We're designed to eat carbs because that's what the tongue is telling us. You want this sweet stuff. But in nature, it just was hard to get carbs because those fruits in nature aren't as sweet as the ones in the produce aisle. They're not as big and juicy. They're small and bitter and tough and have skin and seeds. And so, yeah, if you, depending on what really is the question, is historically, ancestrally, were fruits an important part of the diet? Probably just very seasonal, a little bit of drying of berries and things like that. Not as big a role as we might like with like bananas and apples everywhere you turn and bright oranges everywhere that we have now. But I think fruits are a nice way to have flavor and color, and vegetables the same way. Vegetables bring you texture and diversity and color and interest and culinary possibilities, and you can expand that kind of sort of hedonistic desire to have interesting food. Has its value. You build culture on that, but it's not necessarily critical to human health.
I suppose I've still yet to sort of come to a conclusion on the plant side of things. Definitely not a microbiologist. I'm a chemist, so I look at it more from a sort of a perspective of fats, carbs, and proteins, and all of that. And you raised an interesting point where you said you need, when you said that we need carbohydrates as a species, and I think I would agree with that for the most part. I think a lot of people can get away with a ketogenic diet. However, I think for a lot of people, being in that sort of long-term state of ketosis can potentially have downsides, especially for younger women who are of who are of fertile age. I think when you start restricting carbohydrates, you can start increasing SHBG and thyroid binding globulin and drive and cause all sorts of endocrine dysfunction
Mhm.
as a result of this
Mhm.
over restriction of carbohydrates. So I think for certain groups of people, it's definitely required.
And you can play with the tool of ketosis and go in and out of ketosis and have that metabolic flexibility without having to stay in some deeply therapeutic. I mean, any therapy that needs to happen every day of your life forevermore doesn't make sense as a therapy anymore. And we lose sight of that you can have benefits from a certain technique or herb or anything else, but usually the short-term value is really where it's at. When you start doing something chronically, it has a different effect, and sometimes that effect is harmful.
Yeah, no, I couldn't agree more. You've already touched on it to some extent, but I'd love to sort of go into a little bit more detail with regards to how oxalates are potentially damaging the mitochondria, or our mitochondria, the powerhouses of our bodies, and how they are sort of creating this disruption at a cellular level, and creating an energy deficit within the body. Because I think, based again on my research and my background, ultimately all disease or disease ends up with these little organelles in the cells becoming ineffective at doing their job, which is to create energy. And obviously there are a lot of potential causes for that. They're normally toxin in nature, whether that's mold or another infection. Obviously today we're talking specifically about oxalates, and to a big extent, I suppose, plant defense chemicals. But would you mind elaborating again at a relatively high level, obviously, so it's accessible, how oxalates are essentially creating this mitochondrial dysfunction and this subsequently this lack of available energy?
This is sort of almost a holy idea of, hello, life is energy. You're not alive without energy, and anything that cuts your energy is cutting back on your life. And this is profoundly important to think about energy, energy production, energy availability for your cells. And of course, the mitochondria are the major factories that's managing energy sources and turning them into energy currency that allows your cells to function properly and do all their jobs. And when that currency runs short, the cell's ability to do its job are highly compromised, and then you're on your way to disease. You absolutely need cells that have enough mitochondria that are working well in order to grow, thrive, and maintain your tissues. When your tissues don't make enough energy, they start falling apart. And oxalate is a major energy suck from the body. And it's you're eating it and you can't eliminate it through metabolism. You can't metabolize it. You just move it around the body and try to get rid of it. But in the meantime, every tissue is exposed to, or that is exposed to it, is potentially damaging cell membranes, especially if there's a crystal formation going on because there's a charge there. Cell membranes have this double lipid structure. And this bilipid layer is a very particular structure where certain molecules are on the inside and certain ones are on the outside. Well, it causes a flip where one of the molecules is supposed to be on the inside only flips to the outside. And this is really quite serious because membranes are where energy is produced. Inside membranes sit these big proteins, these enzymes, and these series of enzymes that are happening on all the membranes. If the fatty molecules that make up the membrane are wrong, then the proteins themselves that do this work don't work right either. So now you've got a damaged cell membrane, which is the sort of factory walls and floors that allows your factory to do this energy handling. And so you've got membrane changes, you've got oxidation going on, and that's depleting the antioxidant capacity of the cells. So you start using up glutathione, and then your own capacity to handle that stress goes way down. And so things go from broken to more broken to more broken. And you start damaging proteins, oxidizing the lipids, all these other molecules start to be messed up. The immune system recognizes, starts taking the cells away, but particularly in the mitochondria. So there should have plenty of mitochondria, especially in cells like muscle cells, nerve cells, and so on. You're penetrating the mitochondria with this little oxalic acid molecule and messing with the handling of calcium. So the cells have to have very tight control over these ions of calcium. That's an individual molecule with charge, usually 2 charges on a calcium ion. And this little molecule is a signaling molecule that helps the cell decide what to do when and what it's supposed to be doing. It's very interesting. You have to control that with these suborganelles like the mitochondria and another one called the endoplasmic reticulum, and control what's going on between those 2 organelles with where calcium's moving back and forth. Well, here you have a calcium chelator that grabs the calcium and causes calcium buildup where it shouldn't be and calcium depletion, and just interferes with the entire communication system in a cell. And then you've got the oxalic acid will sit on these enzymes needed to produce energy and to produce glucose. So there's 4 or 5 of these enzymes that where there's a spot there where the active site where oxalate fits in there just perfectly. So these pyruvate carboxylates and so on that generate in the first run when you take glucose and try to turn it into the currency of ATP, you've got this last step that helps produce these ATPs that gets blocked by an oxalate. And then in your electron transport chain down in the mitochondria, you've got complex 2 and so on being interfered with. So you're breaking the machinery itself. So we have this factory, the cell, the floors, the walls are messed up, and now the actual equipment is broken through oxalate interfering with enzyme function. So it's kind of a mess.
Yeah, so if I was to summarize that for the audience at a high level, what's happening is that to start off with oxalates getting to the body, then it's essentially it's damaging the cell membrane layer, which is causing almost the cell to act at a dysfunctional level, but it's also going to cause altered cellular communication. You're also going to then have oxalate sort of get into the cell and start interfering with the cell's ability to utilize calcium properly. I assume that's through some sort of voltage-gated calcium channel, something to that extent. And that is then causing either the influx of calcium into the cell and damaging a cell, because obviously, as you know, if there's too much calcium in the cell, it can cause cell death, cell apoptosis. And then beyond that, it's also at an enzymatic level, it's causing calcium to, if I follow correctly, to bind to specific places in the cell that cause the cell then to not produce energy properly. Would that be a relatively sort of a decent summary, or did I miss anything at all?
Yeah, well, one of the things I didn't mention is that when you get this oxidative damage and or low ATP production, you have changes in the expression, the methylation and the aging of the cell and the protein management. You're supposed to clear unfolded proteins and do all that stuff. All that kind of cell aging gets out of control, and you get epigenetic changes and the cell starts acting differently. So sometimes it turns cells like a normal epithelial cell into a bone producing cell and starts causing calcifications of other kinds because you've messed up the genetic expression. So the cell gets confused about what kind of cell it is, goes through these mesenchymal transitions, and it turns on cytokines that just promote that process. So the cytokines come along to deal with the crystals that are forming in those tissues, along with this basic oxalic acid interfering with the mechanism of the factory. But you've also got this crystallization bringing in additional inflammation, because inflammation comes in when the system detects this leakage of potassium and other problems with the cell, with the membrane structures. It comes along to try to get rid of the broken cell, and that broken tissue creates a room for crystallization, because the vacuole debris stimulates more precipitation of acid into crystals. And then you get crystal adhesions, and now you have more cytokines coming in trying to phagocytize and get rid of these crystal accumulations. And that additional work by the cells turns on the kind of damage that causes cells to go from normal good cells to problematic bone cells and other cancer cells and things like that.
Yeah, basically what you're doing is you are just creating cellular dysfunction at such a high level that these poor little mitochondria are almost completely unable to produce energy. Um, I'd like to sort of take a bit of a stab at two conditions that I think are definitely very prevalent in our society and I think oxalate, based on my sort of reading of the literature, and this is obviously not my field, there definitely could be a very strong oxalate aspect to this. Number one being hypothyroidism, and number two being, broadly speaking, cognitive decline, your dementias, your Alzheimer's, etc. I know I've heard you talk about this before, especially with regards to hypothyroidism. But could you maybe briefly explain the link between, sort of oxalate overload and then these conditions?
Yes, the oxalate overload is so we have diets overload with oxalate, and we're eating enough of this acid, it's getting into your bloodstream to a level that is not only damaging the vascular system and the cells in there, but it's really stressing the excretion capacity of the kidneys. And the kidneys are the last tissue to see oxalate, because it's coming first in your gut, then getting into your vascular system, which goes straight to your liver. So now the liver has this open sinusoidal structures, because the liver is filtering everything coming through and transforming nutrients and catching any problematic things. And it's being, all these cells in the liver are wide open, exposed to the oxalic acid that was in your spinach smoothie and your quinoa bread and your almond whatever, and your chia bowl. Whoa, after each meal, even just hash browns and chips and fries kind of stuff, you're loading up that liver, using up glutathione, and potentially leaving enough oxalate behind where you get some accumulation. But most of it's going to leave the liver. And you know what else happens in the liver is that's where this endogenous production is occurring. So the liver is adding more oxalate to that blood. So the blood that leaves the liver could even have more oxalate than it had when it started from your chia bowl. And it goes just a few inches up to your heart. So now that blood is flowing through your heart, and then it goes into your lungs, and it flows through your lungs, and then it flows back into the heart and out into peripheral circulation. Well, it gets everywhere, and it gets into glands like the thyroid gland, the pancreas, the pituitary. The glands seem to pick up oxalate. Connective tissue picks it up. Tissues that have a lot of calcium handling, like the bones and the breasts. The breasts make milk, so those cells have a special affinity for handling and concentrating calcium. And so it accumulates in the thyroid gland almost universally. By the time you're middle age, you have an 85% chance of having detectable, visible levels of crystals. Like, it can be so small, it's almost indetectable, but it's there. But it's detectable, that's really quite something. And it's also collecting in other tissues as well, your eyes, your brain, the meninges around your brain, that's the sheaths, your teeth, your jaws, your sinuses, your bone marrow. And so this stuff is damaging the function of these tissues. And in the thyroid is not a huge thing, very busy, important master gland. You could be interfering, like we just said, the energy production makes it harder to produce enough thyroxine or various hormones that it's producing, and you're seeming to collect it there, and that the crystal accumulation increases inflammation. So you have sort of a Hashimoto's like kind of pattern because you're bringing in inflammation to deal with this oxalate collection. So there's no question that oxalate is a major player in this now epidemic of thyroid problems and neurological damage. It's very much a neurotoxin. It collects in the brain as well.
Yeah, I suppose that sort of really could explain some of the etymology behind a disease like multiple sclerosis as well. I think we just
Yes.
you touched on myelin degeneration earlier. This idea that within multiple sclerosis, anyway, that it's a disease whereby the myelin the fatty sheathing that surrounds nerves, starts to break down, exposing those nerves to oxygen to blood, which then causes sort of die-off within brain cells, within nervous system tissue. So yeah,
That's a great
I
example of tissue
Mhm.
maintenance problems. The cells that keep and maintain that insulation. And people may not realize, if you think of a cord that you use to plug something in, underneath this vinyl is the charge where all the electrons are running through. So nerves kind of need this vinyl around them to function properly, and that's that myelin sheath. And when it goes away, woo, you don't want that kind of exposure to this electricity generation process and vice versa. So the tissue maintenance occurs on nerves as well as connective tissues and other tissues as well, where you've got an energy deficit and you have a toxicity, and then you have inflammation coming into those tissues. So those cells whose jobs are to maintain that tissue can't do their job because they're so damaged.
Yeah, you just completely create this sort of dysregulation, this sort of excess sort of allosteric load within the body that just causes this complete shutdown of all these systems. And yeah, no,
Well, even
it's
incomplete shutdown is enough. Like, it doesn't
yeah,
even have to be complete. In fact, a lot of this is happening under the hood where you feel fine until you don't. Like, there's a breaking point. Like, it can be going on. Disease is often asymptomatic, meaning you have to have some way to measure the disease process, a blood pressure cuff or something to be able to even detect what's going on. And so the body tries real hard to look good, even if under the hood things are rough. And so it doesn't need to be complete breakdown. And I think it's important to pause on this because in the literature, we often look at the fatal dose. Well, it
the
takes
LD50. Yeah,
5 grams to die from it, so it's okay. Well, wait a minute. What if I just feel like I'm dying? Isn't that bad enough? Do I have to actually die to prove that I'm poisoned?
yeah. No, thank you for catching that. No, it's definitely an important point to remember. Which really sort of was quite a nice segue to my next question. Really, which is about how to identify whether or not it's necessarily an oxalate issue. I mean, yeah, if you don't mind, I'm just going to throw my sixpence worth into the conversation, and I understand that oxalates are an issue, especially if there's a genetic predisposition. However, I'm also aware that there are a bunch of other potential triggers, some of which are plant defense plants defense chemicals, so your FODMAPs, your lectins, your tannins, and then you obviously have other issues, just your proteins and your simple sugars, your
Salicylic acid,
yeah, casein, lactose, your
molds.
all of that. So I suppose my question is there, especially from a plant defense mechanism standpoint, which I suppose is apt because that's the conversation we're having today. How can you be sure that it is an oxalate issue, I suppose, at the end of the day, versus a screaming case of you've just eaten too much cabbage and your FODMAPs are through the roof?
Right, right. So again, there's lots of different angles on this and different stages of when this is relevant. I would say on the side of am I getting sick with something? What's making me sick on this kind of progression towards illness? What was causing it? I'd say the biggest collaborator with oxalate to really get you is the lectins. And so if you have a high lectin, high oxalate diet, that will get you, period. It will eventually get you. I just feel so strongly about that And even if it doesn't get you, it doesn't mean that it's safe. So this is another principle that goes with this, just on this, the first side, there's the end side, like, oh, you're sick, and now what do you do? And now you've done something. How do you know oxalate was the reason you're better? But on this coming into the disease side, you have to remember that toxins that cause disease don't cause the same disease in the same amount of time in every person. So if you think about tobacco exposure or the use of cigarettes, and that's a broader form of toxicity because the filters and the chemicals and the other things done when you make a cigarette adds to the possible and very well documented toxicity of smoking cigarettes. So we put warning labels on cigarettes and we restrict who can buy them. And we add taxes to them to make an incentive for you to not use this product because we know it can cause problems like lung cancer. But does every smoker die of lung cancer? They do not. Very few people who smoke die of lung cancer. Very few. So does that mean we should all just smoke cigarettes and ignore that toxin? Apparently, it doesn't mean that. But people use that logic when they think about something like oxalate. Well, Uncle Charlie's been eating XYZ his whole life, and he's still cutting down trees, and he's 78 years old. Okay, so therefore you can pig out on it or let your pregnant daughter do that or let your child have it as baby food? I don't think so. Because when something is toxic, it is toxic, and you cannot predict who can withstand the toxin and who cannot. So you want to use a precautionary approach and say, you know what, we should find out what generally is a tolerable level of a toxin and try not to exceed that. And that's my whole message with my book, is that we're built to handle 100 milligrams or maybe 200 milligrams max a day, but most of you are eating 600 or 1,000. And those of you on spinach, you could be doing 3,000 a day. And if you're a sick, frail person or a little baby, you literally could kill somebody with that or give them permanent health problems with thyroid dysfunction and even fibrosis of the lungs, because the lungs will try to help the poor kidneys get rid of it. And the lungs is in that first 3 organs that get slammed with it after each meal. So you can get in trouble. So I just want to say, like, is it oxalates? Well, something that's toxic ought to be on our radar, period. Now, when you're sick, like I am, and you finally do a low oxalate diet, when it's oxalate, at some point you start to see the body expelling the oxalates. So you will see it as cloudy urine, tartar on the teeth, gritty stools, skin breakouts. Some people literally get boils that push out whole crystals. Other people start snowing with white dust coming off their skin periodically or constantly. Some people constantly for years. And you can tell, oh my gosh, I have oxalate overload, and now my overloaded body is puking it up all over the place, and you can see it. So you can detect this oxalate overload with the deaccumulation process. And the other way you know it's oxalate is because when you change your diet, suddenly wonderful things can happen. You sleep better, you aren't running to the bathroom all night long, your bladder is functioning better, you stop getting bladder infections, you stop getting yeast infections, you stop getting sinus infections, your vision gets better, your hearing is better, your teeth stop hurting. Like, something good can happen when you quit poisoning your body. You can kind of tell. The confusion is that people think, well, there's probably something else. But once you get a toxin that's also making you nutrient deficient, by the way, and minerals and so on, once you lower your exposure to this toxin and it helps your whole mitochondrial system, your barrier function of your epithelial tissues, all these things start functioning better. And the other problems like your mold and this and that start clearing themselves up.
That's interesting. A little bit off script and probably maybe a slightly technical question. Is there a relationship? You mentioned yeast, so you just I got interested. Is there a relationship between oxalates and fungal infections like candida, do you think?
Yes, that oxalates make you vulnerable to these infections, not that they're producing the oxalate necessarily. There is a slight chance that some bacteria that are related to candida or they're promoted by a candida infection might produce a little oxalate. But what's happening is that the oxalate is wrecking your barrier function and your immune function, and you're a sitting duck for infections. It also causes acidity and pH problems, and that promotes an environment that allows these infections to occur.
Yeah, no, that makes total sense. I'll do some more research on that off there, but no, it was just something that just struck me as being a potential link there.
There's only certain molds that produce oxalate, and most of them are soil molds. And candida is a yeast that is not known to produce any oxalate. So it's not a direct, it's the other way around. It's that oxalates help create an environment where you get candida infections.
Okay. I've learned something. Thank you.
Yeah.
I suppose sort of the natural progression of this question would maybe be to talk about something like oxalate testing. There are a bunch of different options out there. You get serum and urinary direct sort of tests looking at on oxalate, and then you've also got your organic acids tests that are looking at urinary oxalate metabolites. Do you think that these tests are clinically useful for individuals from a clinical point of view, maybe helping them to sort of identify whether oxalates are maybe for them genetically more of an issue than for somebody else? Do you think that they're useful and that they have a purpose, or again, are oxalates sort of detrimental to the point where we should all just be eliminating as much of them from our diets as possible, as a general rule of thumb, if you get my understanding there?
Right. So there's, again, different agendas at play on how important testing is. Culturally, testing has become very important. Patients want some validation that says, here, see, this is really a real thing, and see, it's in my urine and it's seriously high. And that gives them a pass for not being nutsy with their husbands or their children or their doctor or something. So patients want that validation because they want to know something really concrete and physical is wrong with them, rather than being told they're just anxious and crazy. So it has that value potentially if you don't get the false negative result. But I, for example, when I did the organic acids test in 2009, had absolutely no oxalate problem whatsoever according to that test. Not anything was showing up, nothing. Completely clean bill of health. I was so poisoned with oxalate and have been most of my life, and yet the test doesn't catch it. And this is the problem with assuming that biology is like an object on the desk. You cannot expect your urine to be like a pen that never changes except for the ink comes out. It's constantly in flux based on all kinds of metabolic priorities going on. The kidneys are very active. It's not just a blood filtering system. It's a whole management of your metabolism going on with kidneys. They're major drivers of metabolism, major communicator about what's going on in the body. And they want to do different things at night versus the morning versus after meals versus in the spring or during equinox. Like, there's a lot going on that causes a lot of variability. And one of the main things that the body does is help the kidneys not be constantly abused by too much oxalate all the time. So literally, there's kind of like weekends where you get a little break, and that break might always be at 10 in the morning when you took your test or something. Like, there's these cycles going on, which we don't have a clue how this is. So complicated. Maybe some supercomputer in the future will get a better sense of how the body is so brilliant. But to take a static test and say, oh, no oxalate problem, you can't do that. Now, if you get a test that shows elevated oxalate and elevated all kinds of stuff that's oxalate metabolism related, then you want to really believe that. That is for real.
Yeah, no, it's so essentially there's not really, let me see if I can get this right. You're not likely to get a false negative, but you should not ignore a false positive.
A real positive.
A real positive,
Real
yeah.
positive, don't ignore it. If you don't get a positive, you don't necessarily know anything.
Yeah, no, that's fair enough.
You can't eliminate an oxalate problem by a test. You can only eliminate an oxalate problem by doing the diet correctly long enough to see if it's making any difference.
Yeah, and just out of interest, well, actually, you know what, we can tie that into the next question, which I suppose sort of brings us around to sort of how to start getting rid of oxalate safely. I know you've already touched on that with regards to sort of oxalate dumping and the fact that If you do it potentially too quickly, maybe you can almost end up with these, well, you can end up with these sort of Herxheimer-esque like reactions where the body actually starts to excrete oxalate every which way possible. And that can, as you mentioned earlier, sort of manifest as skin issues, as a worsening of current symptoms. How would you counsel an individual who has a high oxalate level to start weaning down and reducing the level of oxalates in their body so that they don't necessarily have these sort of very adverse reactions? Or are those to some extent, can you not get away from them?
Well, first of all, you have to accept that this is a learning process. It's an education process. You have to get educated. You have to take the time to learn. And you can't just be given 3 tips and you're ready to roll and get in action with ignorantly. You don't want to be a soldier following orders. You want to be an informed person. So you're going to need to take time to even examine your diet and think about how much potatoes you've been eating, if you're using too much quinoa, beets, or these dark leafy greens, these 3 ones that are high in oxalate. Other ones are fine, but you need to get to know the data. And you can't just do a Google search because there's a lot of bad stuff on the internet. I do have some free stuff on my website. Toxic Superfoods, the book, has many lists in there that are simple. And if you want detailed data, I've assembled it in a book you can buy just on my website, and you can learn and you can get a quick sense of like what things are high and low by just looking at the color coding. Things that are white, green, or yellow are fine, but the things that are in the darker orange and red are things you need to be really thinking about. Are you eating them? So you can think about your diet, what you've been doing recently, what you seem to like doing, and find these worst offender foods and pick one that you can live without and learn how to live without it, like Swiss chard. Who cannot live without Swiss chard? Like get practical. And so you start to learn what those are, and you start to be, because you're modifying your shopping cart, your cooking habits, what you order when you eat out. Your whole life rhythm can be built around your meals and your meal prep and meal planning and your budgeting. So it's important to start thinking in that way. Like, how does a human being gradually change in their habits and their thinking? So give yourself some patience. That's the main thing. I know we want to just talk, well, the science part and so on, but it's really important that you're a human being and you are a microbiome. Like, you're also changing your microbiome whenever you change your diet in any way. And the more gently you can do that, the better. Now, your body's been dealing with every meal you've been eating, some probably oxalates at most meals. And these waves of meals are keeping your blood level high. And when you start taking these foods out, the amount of oxalate in your bloodstream comes down. If it comes down really abruptly, the body can hear that's a signal, right? That's a signal. Big, high oxalate, very little oxalate, and you stay little oxalate for just 3 days. It's all it takes for the body to go, oh, the bloodstream is open. It's open area. We can now get it out of the thyroid gland. Yay. And then you bring in inflammation and try to bring out the thyroid gland. So you look at your worst offending foods and decide that you can live without peanut butter, Swiss chard, almonds, almond milk, almond this and that, cashews, fake cashew cheese, and you keep picking them off one by one. And basically you want to get a sense of, well, wow, I've been eating over 800 milligrams on a typical days. And on days when I do my double fudge, whatever brownies, I'm at 1500. And on the days that I do my spinach smoothie on Saturday mornings, I'm at 2500. Like, then you can just knock off the 2500 days. You want to get out of that toxic danger zone of a consumption and bring it down. And even if you bring it down to like 200, even 400, you can start to benefit without maybe inspiring a riot. You might say, the tissue's like, yeah, man, we can get rid of this stuff. It's better to leave all this accumulation where it is and just stop accumulating and stop flushing all your organs and your vascular system meal after meal after meal. And you could do it another way. You could do it and just say, well, I'm going to make sure every breakfast is oxalate free or every dinner is low oxalate, and learn how to do that. So there's a whole individual process, like what works for your lifestyle, your personality, and your family, how you actually do it. But what all you need to know is that this is not a 100% elimination diet. This is not a gluten-free allergy thing whatsoever. This is about toxicity. You have to get out of that really toxic zone. And so that means almost any high oxalate food could be reintroduced, because you could go back to having hot cocoa if all the other oxalate foods are out of your diet. There's room for any of them, but just get rid of the ones you know you can live without, and then start getting gradually moving towards a sensible diet that's going to work for you, hopefully not triggering this excessive deaccumulation that can create an illness, because you could literally cause disruptions in the ions in your blood, because you're putting acid back in your blood. You drop the calcium levels as it grabs that calcium. You have hypocalcemia, which can cause pacemaker problems, arrhythmias, super spikes, and hypertension, and you feel like you're having a heart attack because you're having electrolyte crises. You may be acting like you've had a stroke and dragging your left side around. It can get really serious when you mess up your blood electrolytes and have this inflammation going on at the same time.
I suppose, well, what I've taken from that is it probably shouldn't be sort of this binary execution, i.e., don't just jump straight onto a carnivore diet if you think you've got an oxidant overload. And B, yeah, as you've just alluded to, yeah, just take it slowly. Supplements. I think you mentioned calcium. The other one that springs to mind is vitamin B6, which I know is involved in the clearance of oxalate. Specifically B6, if my biochem is correct, I think it helps convert glycoxylate into glycine instead of oxalate, I think.
Right, back and forth. I think it's on both enzymes that can turn glycine to oxalate or turn oxalate back into glycine, and or hydroxyproline, which is more likely. But you also have B1 or thiamine is turning oxalate into non-toxic chemicals, and without enough B1, well, not oxalate. See, the mistake we're making is this precursor to oxalate. This precursor, there's actually three: glyoxyl, glyoxylate, and so on, that are in there, that are toxic in themselves, acidifying in themselves, but they're a precursor. These enzymes can shunt that and protect that from becoming all oxalate if you have the cofactors. That's what vitamins are. They're cofactors on the enzymes that make metabolic transformations and turn one molecule into a different kind of molecule. So you need these B vitamins on these transforming proteins so they can protect us from excessive production of oxalate in cells. The liver, the kidney, and red blood cells are mostly where this is happening. That doesn't really protect you from the excess of vitamin C that can just turn into oxalate without even enzymatic. Both vitamin C, there's both enzyme pathways that turn it into oxalate, and there's just just spontaneous. Like literally in a vitamin bottle of vitamin C, it can turn into oxalate just sitting there. So the vitamin C is interesting because it gets into all cells. And it's any cell in the body can accumulate vitamin C and start having oxalate formation in the cell with or without the enzyme. So that's where the B vitamins are not protecting you from that vitamin C necessarily. So yeah, the supplements are very important. We've now created a mineral deficiency by overeating oxalate. And calcium is the binder that helps you remove oxalate from the body safely and gives it a whole lot of buffering capacity to handle these wobbling hypocalcium attacks that happen as your body's trying to release oxalate. So you need a lot of calcium, and the supplement form is excellent for doing this. It is the number one medicine for people who are oxalate poisoned. Does not cause calcification of your arteries. Calcification of the body is because of what we talked about before, where the cells are damaged and now they're turning into bone cells, and that's the damage side. The calcium helps prevent further damage, the supplement calcium. So alkaline minerals, with calcium being the main one. Potassium is being leaked out and lost in the process. So potassium is very important. Most people are deficient in it. Usually there's a need for magnesium, and often we like to see these in a citrate form. You can also use some of them in a bicarb form because there's a lot of acidity going on, and the alkaline minerals help address some of that acidity. The bicarb helps doing that. And then there's citrates. So citric acid comes from lemon juice, but we also use citrates to deliver these minerals in supplement form. So often we suggest you start with the citrate form of at least the calcium, or the you can do that with magnesium as well, and so on. But you can play around because it's a separate issue. But the citrate prevents crystal growth and helps the hard crystals that are hard like quartz. It softens them because citric acid has such a strong affinity for calcium that it's even stronger than the oxalate affinity for calcium. So when it sits on a calcium oxalate molecule, in comes citrate, it actually loosens the bond between oxalate and calcium and makes it more chalky, softer, and then you can break it down easily. So it destabilizes that sort of crystal lattice.
It's more easily cleaved off, yeah.
Yeah, so it's really just weakening the bonds, but it turns quartz into chalk, so you can get rid of it. So the citrates are really great, and when the cells have the right pH, they can generate citrate themselves. And the urine needs to be high in citric acid. That would be a good test to run, is how much citrate your kidneys can put out, because that's protecting you from kidney stones. So for people with a history of kidney stones, we might look at that. So those are the main things where you can use B vitamins, the minerals, and citric acid. Those are the main ones. And then there's other things that can help along the way.
Calcium, EDTA, etc.
Yeah, and just generally supporting the damaged nervous system with things like choline, or it depends on that person's issues, but even, occasionally needing aspirin, things like this, because there's so much inflammation going on. So you need a little bit of support, but I like to use as few oral things. You can even use mineral baths and topical things to really support this process. Oftentimes you have problem with digestion with these folks, because you almost always have some digestive dysfunction, either because the nerves aren't working right, and now the muscles of the sphincters are damaged in their function, or the whole, many of the tissues in the gut are a little distressed. There's immune tissues, and just the general absorptive surface is not good. And then you have potentially some problems with bile production, production of anything from the pancreas, including your insulin, but also the digestive enzymes and so on. So it depends on what's going on, what other supplements might be useful.
Yeah, and I think what's important to take away for the listener is that what you've just alluded to can get very complicated. But at a high level, if you just start to slowly reduce the total oxalate, your total oxalate intake, you are very likely to sort of resolve the majority of these issues without necessarily needing to get to this point, especially if you're still in the state where you are not feeling 100%, but you're not necessarily in that I can't get out of bed point.
The earlier the better.
Yes, of course. So
because this is really, those of us who've really messed up our lives with oxalate would just wish to not have anyone go through what we've been through. This can be very devastating and bring people to the brink of some serious problems that could be very hard to live with, and the recovery process is not quick. It might be 10 or 15 years of recovery.
Yeah, no, you've got to rebuild the body at a cell by cell level. Sally, I know we're starting to run short on time, but to sort of end off with, I'd love to ask you just a few rapid-ish fire questions. These never end up being rapid fire, but
we'll try.
we'll do our best.
See if we can win the game.
Yeah, we'll do our best. The first one is going to be about as rapid as I am first thing in the morning without caffeine. But, and this is something we had discussed previously, but why isn't this a bigger issue? Why isn't this being sort of looked at a more institutional level? Why is it being swept on the rug? I'm sure we could get somewhat conspiratorial, but what are your thoughts there?
Well, the fast answer is read my book. There's a chapter on this, and it talks about the failures in medicine and nutrition and so on of ignoring this. And some of it, literally, the system is rigged to keep disease processes going because researchers need careers, and you can't solve the problem you're studying because then you're out of a job.
Yeah, no, that makes total sense. Okay. Nice and simple. Next one. What's the one high oxalate food that people would be surprised to learn is problematic?
Well, Buckwheat, quinoa, chia seeds. I would say most people are shocked at the spinach one, but anyone who knows anything about nutrition is not shocked about that. So if you're shocked, go back to 101 nutrition class because hello. And bran is another one, but bran was fashionable in the 80s. I guess it's a little fashionable again, but those are key ones. And I would say generally, gluten-free stuff, almost always high oxalate. And keto stuff, the chocolate and the almonds and so on. Yeah.
Yeah, no, I was going to my pick for that would have been chocolate. I think most people
Yeah.
get a nasty surprise when you say that 90% lint that you're eating. Yes, it's low in sugar, but it's
High in lead, cadmium, and oxalate, folks.
there we go.
Yeah, but I try not to break that news because I don't want to get hit or shot.
Yeah, no, it's you are dancing the fire a bit there. Okay. What? Here's
Oh,
another
another one.
one.
Let's
Hmm.
turmeric.
Yes, of course. Yeah, and I think you
The
can
whole root
bypass.
turmeric, but
Yeah,
curcumin
curcumin.
extracts are not. Yeah, so if you're interested in playing with the extracts, they're no problem.
Perfect. What's the most common misconception about oxalates that you encounter on a day-to-day basis?
Oh, most common misconception about oxalates. Well, you have to have renal failure or kidney stones for it to matter. If you haven't had a kidney stone, you can have all you want. No, you have a lot of other tissues that care, including your precious teeth and your eyes and your thyroid gland and your vascular system and your immune cells and your liver and a few other things.
Your desire to live, yes.
Your desire to live and not be feeble and not be old before your time, because I believe knowing about oxalate and getting them out of your life, you found the fountain of youth.
Yeah, no, I couldn't agree more. And the last one, um, maybe a bit of a controversial one and something we've already discussed in passing already. But what do you think about the carnivore diet in relation to all of this?
The carnivore diet is an excellent demonstration of the need and value of meat products, meat in the diet. It's also a very handy elimination diet that'll help you take a break from lots of chemicals and lots of confusion about what dietary things might be influencing your health. The thing is, too long in a carnivore diet could actually increase your intolerance, potentially, if you have oxalate poisoning to some plant foods. So I don't know if that's really true. We really need research on that. And it is essentially a zero carb diet, and day in and day out of zero carb is going to be kind of rough. You're going to have some degree of insulin sensitivity, so it's going to take a while to get you tolerant to some carbs again. If you're needing to go back and diversify your diet, you need to be patient. But I I really love that people seem to be thriving on carnivore because too many people are under eating protein. Guys who are working out like crazy and aren't putting on bulk because they want only like 3 ounces of meat twice a day. That's not enough meat. To me, I think you need 5 ounces 2 or 3 times minimum. Like, I'd like to see people be more comfortable with meat and protein.
Yeah, I think sort of aim for that 1 gram of protein per kilogram per pound of body weight is a reasonable assumption. Whether it's lean mass or not is up for debate. But yeah, no, I couldn't agree more. The RDA on protein is woefully low, and especially as we start looking at older populations that already have protein malabsorption issues and assumedly
Like the
oxalate
elderly.
issues. Yeah,
Yeah,
then
for sure.
yeah.
And I'm just shocked at how many people work out multiple times a day and they won't eat protein. Like, mm, you could look extra cute if you ate, well, just don't eat the whole thing, eat enough. So that's the beautiful thing about carnivore is that people can pile their plates with animal foods and thrive on it, it seemingly.
I'm definitely looking forward to seeing some longer term anecdata there. I mean, Reddit is obviously full of and some potentially some studies, but I think the anecdotal evidence will come first of people who have been on this diet 5, 10, 15, 20 years en masse. I mean, obviously you've got your Sean Bakers of the world, but I think they are more the exception than the rule.
If I can
Uh,
interrupt you and just
of
say
course.
the biggest downside of carnivore is that chronic ketosis means chronic low grade acidity, which breaks down your connective tissue and
Mm.
promotes osteoporosis and maybe cancer. So I really think you're going to end up with connective tissue issues. Your old tennis elbow and your old football injuries are going to come back and kick you hard if you're not at least correcting the pH and not getting enough minerals, and maybe even just getting out of ketosis once in a while. But I do think the downside of chronically using an elimination diet like that is quite serious. If you want to be fit and healthy, you may lose your ability to have healthy joints and bones.
I think some of that, and this has definitely turned into a very unrapid fire question.
Sorry.
No, it's my fault as well. Could be mediated by that ingestion of protein and then the breakdown of that protein into sugar through gluconeogenesis and all of that. But no, fundamentally, I do completely agree with you. I think that if you look at it sort of from an evolutionary, anthropological, sort of whatever term you best identify with, viewpoint, you'll sort of note that people sort of ate seasonally. They went in and out of these dietary patterns. Nobody stuck to anything, at least again based on my view of the literature, indefinitely. There were always sort of shifts in and out of these dietary patterns, which I think sort of speaks volumes to how we should eat, generally speaking, anyway. For this, caveat being exclude oxalates, but yeah. Sally, you've been an absolute angel and a star, and thank you so much for this conversation. I have a feeling that this is a pretty easy one to answer because all people really need is Google, but where's the best place that people can find you?
SallyKNorton.com. SallyKNorton.com is my website. There's a lot of free information there. There's free downloads. That's the only place you can get the data for oxalates. Don't try to get some knockoff off Amazon. And you can find me on Instagram, mostly for social media. I don't spend a lot of time on the other channels much, but I also have a YouTube channel. I really encourage people to come visit Sally K. Norton, or it's SK Norton, either one. YouTube channel where we have testimonials. We have about 13 there. We have about 22 shorts. These are just little 1-minute videos, and you may find one or two in there that will help somebody else discover this topic. Those little 1 minutes you could probably barter for 1 minute of someone's time. So hopefully you're using that YouTube video channel of mine to help other people benefit.
Of course. Yeah, and we'll be sure to link to all of that in the show notes when the podcast is obviously live. Sally, thank you so much again. I really do appreciate it.
Thank you. It's wonderful to be with you, and I'm so glad your audience is going to take an interest in oxalate. Thank you.
Thank you.